yesterday. But the only trick is that this is the section where word problems can have multiplication or division with them. So we just have to be thinking about that. But even in a real life situation, we wouldn't know if it was addition, subtraction, multiplication, or division. So we'll just take a cue from the words. Here's the word problem. Ingrid walked her dog and washed her car. She spent 3 times as much time washing her car as walking her dog. It took her 1.5 hours to wash her car, and the question is, how long did it take her then to walk her dog? So let's take a look at the words here. What are some key phrases or some things I should be like circling and kind of putting my attention to?
$150.
What's that?
Wait. Oh,
we're looking at this side over here.
Yeah, sorry, I got confused. She spent 3 times as much washing her car.
So that word 3 times as much, I'm sorry, that phone's just going to keep going. 3 times as much, that means that's telling me it's multiplication, right? 3 times.
Mm-hmm.
Okay, what else is important information to know?
It took her 1.5 hours to wash her car.
I like it. So not just 1.5 hours, we want to make sure we know what that 1.5 hours goes with. And you know what, I just like making these notes. 1.5 H equals wash car. That's just some little notes I make, and it kind of I'm starting to now the process of taking these words and putting them into an equation of some sort. What else do we know? What else did she do? So we know something about washing a car. We know 3 times. What else do we know?
We're supposed to find out how long is it gonna take her to walk her dog.
So we're going to put a question mark hours here for walk dog. That's what we don't know. And I like that question mark, so I'm going to change that question mark to a variable. So instead of putting a question mark there, what variable should I give for walking the dog?
W.
Okay, W for walking the dog. W for walking, okay? Mm-hmm. So now I know whenever I find W, it's gonna be walking the dog. All right, so now I'm looking at a relationship. I'm trying to find some relationships then from up in here between washing cars and walking dogs that I can use to write an equation. What do I know about her washing a car and walking a dog?
She spent 1.5 hours washing a dog. Washing the car.
Okay, so 1.5 equals washing the car. What else do I know about washing the car?
She spent 3 times as much as washing the car as walking her dog.
Let's key into this relation. 3 times as much time washing her car as walking her dog. So washing her car, did that take more time or less time than walking her dog?
It took.
It says 3 times as much time washing her car as walking her dog. So I have to think, does that mean she spent more time washing her car or more time walking the dog?
More time washing her car.
Washing her car. So whatever she spent on washing her car, it was 3 times she spent walking the dog. Remember that W stands for walking the dog. Now, I see from this word problem, I know 2 things about washing the car. I know it took her 1.5 hours, and I know it was 3 times whatever much time it took walking the dog. So I can just cover that part up. Now I have an equation. So 1.5 hours, and I should probably keep the H there. Let me go back and put those units back. 1.5 hours is 3 times W. And I think, I'm gonna leave it that way. So now I have to think about, okay, so 3 W's is 1.5 hours. What would 1 W be? What would just be walking her dog? I don't want to know what walking her dog times 3 is. I already know that's 1.5 hours. I want to know what just walking the dog is.
So do we have 2 variables there?
We do have 2 variables, except one of them they already told us the amount to. We do have 2 variables, but the problem gave us an answer, gave us a solution for one of the variables.
So is H a variable or a unit?
H is a unit.
Know the difference.
It's a unit.
Because it's really
Well,
not a variable there. I'm not trying to isolate H or find H.
no, it means hours. So I guess one thing is to write hours. One thing is to know that I only have one variable, which is W.
Okay.
Yeah, I was thinking about that when I put the hour. You could drop the units, you could take off the units and just know we're talking about hours if that gets confusing.
Yeah, okay. Because I would probably drop the units just because it would confuse me, but I don't know.
Drop the units and just know that it's 1.5, not 1.5 minutes. It wouldn't even make sense to watch the car in
Write it
1.5
down
minutes.
below, like maybe write hours down below or
We
something.
put the hours afterwards. That's a good idea. I was hesitated whether I should put the units in or not for that very reason. So I like that quite a bit. So now I want to think, well, how much is W? I don't want to know what 3, remember this is like 3 times W. So if I want to just have W alone, I need to divide by 3. Remember when I put this symbol in there, it means divide by 3. If I'm going to divide this side by 3, I need to divide this side by 3. Remember that's dividing by 3. So on this side, I'll have W, and I'll have to think what this means. 1.5 divided by 3. Now I could do this. Does that look right? Now, in order to do this, I would have to change 1.5 to 1 and 5/10 and 3. I could do that, or I could be thinking about what does it mean to put things to divide into 3? It means to put them into 3 groups. So I can just be thinking about this, meaning 3 groups, right? When I'm dividing, I'm putting things into groups. Is there a way I could put 1.5 into 3 groups? If I could break up 1.5, how could I put it into 3 groups? And how much would be into each group? Anybody have any thoughts?
Great. Glenda, Nichelle, are you there?
I mean, we could do this problem. And if we didn't have any other thoughts that came, we could do this. So I would have to change 1/2 into 5/10, 1.5 into this. And I could, well, there's a few ways I could do it. I could do it this way. And I put a 0 here, and then I bring the decimal straight up, and 3 goes into 15 5 times. And I could do that. Or I could do it as a fraction. Try to get myself over here. 1.5, which is good review right now, divide by 3. Okay, so I have to make this improper. 1 set of 2 plus 1 more is 3/2 divided by 3, and I want to change the 3 into 3/1. I want to make it also improper. I can't divide fractions, I can only multiply. So in order to multiply, if I change that problem, I need to do the inverse here. I'm doing the inverse operation, the inverse here. When I multiply the numerators, 3 times 1. I'll multiply the denominators, 2 times 3. I get 3/6, which is equal to 1/2. 1/2 5/10, it's the same. Or I could be thinking about, I could have thought about, oh, 1.5. Oh, I know that 1 is equal to 1/2 and another 1/2. So 1.5 is equal to 1/2 plus 1/2 plus I have another 1/2. Oh, 3 groups. I can put 1/2 of an hour in each group. So either way you come at the problem, the answer is 1/2 of an hour. Took a 1/2 hour to walk the dog and an 1.5 hours to wash her car.
I might have drawn a fraction bar. I might have drawn I would have drawn 2 whole fraction bars. And would have, known that I had 1.5, and I would have divided the other one into the 1/2, and I would have seen that I had 1, 2, 3 halves.
You didn't have this part, so you have a 1/2 here.
Sometimes they shade the part I have, and sometimes they shade the part I don't have. But yeah, that would mean that I had 3 halves. So 3 halves, 1/2 in each one. So 1/2, I would have gotten it that way. 4 different ways to attack that.
So we're feeling pretty good that our answer makes sense. It's an hour and a half. An hour. I mean, an hour.
I think so. I'm confident. Everybody else confident?
Sounded good. All right. I wanted to make sure that I looked a little bit at 11.4. This time I could say point because it's a module, 0.4. And 11.4 is the difference between that is that now I have some equations that are inequalities. So I'm going to write that over here. Inequalities. That means they're not quite equal to. Something's a little bit more, something's a little less. They are not equal, but I can still use a math symbol to show it. And I think you guys will get pretty good with it. Let's check it a little bit. Let's look at this scenario. A child must be at least 48 inches to ride a roller coaster. At least 48 inches. So, keywords, 48 inches. What's another key phrase or keyword that I didn't circle? As we're all missing Disneyland and roller coasters and things like that. What about this word here? Or these two phrases together? What does it mean that at least? What does it mean if I say you have to be at least a certain size to do something? What does that mean? Okay, here's a different question. Can I ride the roller coaster if I'm 48 inches tall? Who's out there? Is anybody there with me?
I'm here.
Okay. Can I ride the roller coaster if I'm 48 inches tall?
Michelle, she's here in the chat too. She says, yes, you can.
I can. Okay. Can I ride the roller coaster if I am less than 48 inches?
You mean like if I'm 47 inches?
Now, what if I was 47 inches? Could I ride the roller coaster?
I vote no.
Okay. So I have to be thinking about this. So here's what we can say. I can put height. I'm going to say h is equal to height. So in order to ride the roller coaster, my height has to be more than 48 inches. But if I'm 48 inches, whoever responded said that yes, I could ride it at 48 inches too. So I could ride the roller coaster at 48 inches, and I could ride the roller coaster if I was anything above 48 inches. So if I was 49 inches, or if I was 48 and a half inches, or if I was 60 inches, I could ride the roller coaster. Now, they're asking you in the problems to graph the solution. Just showing me all the possible solutions. Now, if I was going to graph the solution on this problem, the answer is 1/2. So I just make a number line. I'm going to throw 0 down there. I'll put a 1 here. I'll mark this spot as 1/2. And I'm going to graph the solution. There is only one answer. It can only be 1/2. I'm going to graph right on 1/2. But now I'm going to look at this problem. On this problem, 48 inches, well, I'm not starting, if I'm going to put a graph on here, I am not going to label this first one as 0 because I'm going to have to go all the way out here to 48. I'm going to see my answer, okay, 48. I'll just go over here, put 47, 46, and these lines mean it goes on forever. So I'm just zooming in on that part of the number line. I'm going to save myself a little bit of work here. Now I know that 48 is where I want to be. And it's everything more than. See that arrow says it's more than? So it's all of this. Everything in between. 48 and 1/10 of an inch. 48 and 100th of an inch. And all the possibilities. Oops, somebody stopped me here. Oh, well, it was not 47. That should be 49. Okay. Anything from 48 and up. Now, the only thing I have to decide is, can I write it at 48? And yes, because at least means you can have that and more. So now I'm going to color this in, because 48 is an answer, and every number, however close to 48 or far away from it, will work.
Every number greater than 48 and every number in between. But not whole numbers either, right? So what are the other numbers? Not whole numbers. They're not integers, not whole numbers, but all of the rational numbers.
They are all the rational numbers in that space. So everything from yeah, hundredths and thousandths and millionths of an inch even, all of those pieces all the way down. But 48 is an answer too, so I'm going to underline that as well. So let's take a look at this scenario. The goal of the fundraiser is to make $150. Oh wait, I think I didn't write that well. I wanted to see if it was more. Where did it go? I don't like that one too much. Well, we'll see. The goal of the fundraiser is to make, I'm going to say at least, because who wants to just make a minimum amount, is to make more than, I'm going to write it here, is to make more than $150. When you're doing a fundraiser, you don't just stop, right? You want to make as much money as you can. So I'm going to change that to more than $150. All right, so I know this number is important, numbers are important. What's a phrase that I want to be keying into that's going to help me here? I'm going to look for that phrase that says more than. And that's what's making at least more than, that's what's making an inequality. It's not saying to make exactly 150. We want to make more than 150. So what would I do here? Okay, I'm going to write an equation. I'm going to go back to my purple. I'm going to say what my variable is. I'm going to put F for fundraiser. I could put M for money, but fundraiser, that's going to be the money I make at the fundraiser. It's the money made at the fundraiser. F is going to be the money I make. So F is the money I make, and I want it to be more than $150. Remember, the greater than sign, the larger opening always points to the greater side. Okay, greater than 150. So is the goal to make just 150? It's more than, it's not more than or equal to, it's more than. So this time when I graph the solution, I'm not going to be just satisfied with 150. My goal is even going a little higher than 150. Even $151 will help me with my goal. So this time, again, I'm not going to start with 0 over here. I'm going to start with 150. I'll put one number to the left, one number to the right, and so I can just zoom in here. This time, I'm going to always start by putting an open circle that I think about it. Okay, greater than. I love these problems because the symbol shows which way I go with the arrow anyway. 150. And this time, I'm not happy if I just make 150. I want to make more. So this time, I'm not going to circle that in. I'm going to leave it open. So anything more than 150, I'm happy with. 150 or less, I'm not happy with on the fundraiser. So I'm leaving. That's not a solution.
But if it would have said the goal of the fundraiser is to make $150 and you were going to graph the solution for that, wouldn't you graph, you would still graph everything greater than $150, wouldn't you?
I would, and I would include 150 then.
Okay, good. Yeah, I was thinking. So, all right.
I do that. Maybe I did write the word problem right. I just wanted to be a little more clear.
Yeah, because I was thinking like, even if it had only been the goal of the fundraiser was to make $150, and then you said, well, how much money would they have to make? So $150 and everything greater than $150 would be still be
the goal.
Right. I just was thinking that.
Yeah, I was too, but this way makes the problem just a little bit different than this scenario.
Absolutely.
That too. All right, here we go. There are fewer than 8 gallons in the tank. Hopefully you don't have too far before you go to a gas station. Hopefully you're not in the middle of nowhere. All right, same situation. These keywords of fewer than. Notice that in the other situations we have is this, right? She did this and it is this amount of time. Or it's equal, it's giving me some is relationships. This one's giving me things at least, more than, fewer than, almost, things like that. So I'm not going to have an exact number. Fewer than 8 gallons, so I know 8 gallons is important. So what are we talking about in the tank of the car, right? So I'm going to put T is going to be my variable, and it's going to stand for the gallons in the tank. So what relationship can I write? The gallons in the tank are less than 8. Fewer than. So this time the less than 8. If I were going to graph that, I like having my number line in red. It shows up a little bit better when I want to graph over it. And this time I could start with 0, but you know, don't have to. So if we don't have to, why would we? And take a page from mathematicians. They write the least amount as they can. I'm going to write the least I can too. All right, so I'm going to start with 8. And this time, Sarah's pointing this way, and that is exactly on the number line pointing that direction that way. So, and it says less than 8. It didn't say that it was 8 or less. It said it was definitely less than 8. So I'm leaving this circle open, that I don't have 8. Hopefully I'm really close to 8. Hopefully I have 7 and 98 hundredths of a tank, and I'm almost there. So that's that scenario.
What are you wondering?